Okay, we're moving on. We're on page 29. We're going to talk about limiting and excess reactants in the wake of having done the Teddy Graham s'mores activity. So, first, let's do some definitions. We kind of went over this in the s'mores activity, which I did not make a video for, but the limiting reactant is the reactant that is used up completely and it tells you the maximum amount of product that can be made. Okay, think of this as in your group, this was probably the Teddy Grahams. The number of Teddy Grahams you had, all of them got used, and that tells you the maximum number of s'mores you could make. Your excess reactant is the reactant that is not used up. There is always some of this left over. So that would be the marshmallows and the chocolate chips in the activity your group just finished. I would say for most groups, I guess it's possible. Some groups it didn't work out this way, but for most groups, you had leftover marshmallows and chocolate chips, and you ran out of Teddy Grahams. So, first, when you're doing a problem, how do you know if it's a limiting reactant problem? Well, check if you are given a mass for each reactant. If so, it's a limiting problem. So they will, you will be given two numbers, and they will both be reactants. Now that's different from a percent yield problem. A percent yield problem could give you two numbers, but one would be a reactant and one would be a product, because a yield has to be a product. If it's both reactants, this is going to be a limiting problem, and then there are some steps to follow. So as long as you know if it's a limiting reactant problem, all you have to do is follow these steps. Step 1, start with the moles they gave you of the first reactant, and you're going to find moles of the desired product. Now that will be moles and moles, so guess what? That's going to be 2 fractions. That's easy, 2 fractions, so fast. Okay, then for step 2, you're going to start over with the moles they gave you of the second reactant and find moles of the desired product again. So that's moles and moles again. This is going to be 2 more fractions, different ones. Then you're going to have 2 answers. Look at your 2 answers. You're going to have 2 answers of moles of product. Find which one is the larger number of moles, and you're going to cross it out. The moles of product that was a smaller number is the actual amount of product formed, and you're going to put a box around this number as part of your answer. Okay, the one that's a larger number we crossed out because you're not going to be able to actually make that much, because you're going to run out of stuff before you get to it. You're going to run out of stuff when you make the smaller number. So the limiting reactant is the reactant or the given that you started with to get the actual amount of product formed. This is the thing that gets used up first in the reaction. Again, for most of you in the activity for the s'mores that we just did, for most groups, that's going to be the Teddy Grahams. The excess reactant is the reactant or given that you started with to get the number of grams of product that you crossed out. Sorry, this says number of grams. Let's just say number of moles. The excess reactant is the reactant given that you started with to get the number of moles of product that you crossed out. That's the excess reactant will have some leftover unreacted when the limiting runs out. You know which reactant is limiting because that reactant makes less product, and then you run out and you're done. Like with the Teddy Grahams, you could make fewer s'mores and then you run out, so you must be done. You know which reactant is excess because that reactant could make more product, but not enough of the limiting is present to actually make that much product. So like, you may have had 8 marshmallows, but you couldn't make 8 s'mores because you ran out of Teddy Grahams too fast. You may have had 10 chocolate chips, but you couldn't make 10 s'mores because you ran out of Teddy Grahams too fast. Let's look at the next page. Number 1 says 4.7 moles of carbon react with 4.7 moles of oxygen to produce carbon monoxide. Moles of carbon, moles of oxygen. So they gave me 4.7 moles of this and 4.7 moles of that. So I have two givens, and they are both reactants. And according to our notes, if you are given two numbers and they are both reactants, then this is a limiting problem, and you gotta follow the steps. Step 1 says start with the moles they gave you of the first reactant and find moles of the desired product, so two fractions. So our first one was 4.7 moles of carbon. So 4.7 moles of carbon, and we need two fractions because we're going to find the product, which is, there's only one product here, so it must be the CO. So what goes up must come down. Moles of carbon are going to come on bottom. Once you have moles on the bottom, that's your signal. It's time to use the bridge. And according to my bridge, there are 2 moles of carbon. And if I follow the bridge to the end, it's pointing at 2 CO. Remember, this is a mole bridge, so that's 2 moles of CO. And we get 4.7 moles of CO from that. Okay. That was step 1. Step 2, start over with the moles they gave you of the second reactant and find moles of the desired product. Again, 2 more fractions. So I draw 2 more fractions. This time I'm starting with the other one, 4.7 moles of oxygen. And that means my bridge this time is going to go from oxygen to CO. What goes up must come down. We got moles on the bottom. That's my signal that it's time to use the bridge. There's no number in front of oxygen in my bridge. That means I'm just going to use 1. When I cross the bridge, it says 2 CO, and again, we already talked about that's 2 moles of CO. When you do the math here, you get 9.4 moles of CO. Okay, so now I have 2 numbers, 2 answers. If I go look at my steps, it says look at your 2 answers of moles of product, find which one is larger, and cross it out. 4.7 versus 9.4, this one's larger, I'm going to cross it out. The moles of product that was a smaller number is your actual amount formed. Put a box around it as part of your answer. Oh, I already did that because I'm so good. Step 5. The limiting reactant is the reactant, the given, that you started with to get the actual amount of product formed. It's the thing that got used up first in the reaction. So, this thing that I boxed is how much product I can make. The limiting reactant is what I started with. So this is like my s'mores. And the thing I started with is the limiting reactant. That's like my Teddy Grahams. They want to know the limiting reactant. Remember that your s'mores, or the CO, that's a product. That's not the limiting reactant, because that's a product. They want to know the limiting reactant. It's the reactant I started with to make this amount of s'mores, or this amount of product. So it's not CO, because that's a product. The limiting reactant is just carbon. The excess reactant is the reactant or given that you started with to get the number of moles of product that you crossed out. So I crossed out this one. So the excess reactant is what I had before that gets me this number. This is a number of s'mores I can't make because I'm going to run out of teddygrams at 4.7. I'm never going to get to 9.4. I can't make 9.4 s'mores. I run out of teddygrams after I make 4.7. So this over here, this is like the marshmallows or the chocolate chips. Because this is stuff where I have almost too much of it. I have enough of this that I can make all 4.7 s'mores from the teddygrams, and then I'm even going to have some left over. So this is my excess that I have extra left over of, the O2. Again, remember the reactant in excess is O2. CO is a product, it's not a reactant. It's over there on the product side. So how do you know which product is limiting? This is a typo 2. This should say reactant. How do you know which reactant is limiting? The carbon is limiting because it makes less product. There's a bonus. How many grams of product form? Well, this is how many moles of product form. So if I actually just did 2 quick fractions to turn those moles into grams. Then you've got an answer for this. It's just a quick bonus. I'm going to let you try number 2 yourself in a bit. There is that same typo is down here. This should say reactant. Let's turn the page. I want to look at number 3 with you. So we're going to turn the page. Again, real quick, let's fix these typos. This should say reactant right here in number 3. And that same typo is still there in number 4. But I want to do number 3 with you. The reaction between 50 moles of silicon dioxide and 100 moles of carbon produces silicon carbide and carbon monoxide. For each reactant, calculate the moles of product formed and then figure out the limiting. Notice they did give us 50 moles of silicon dioxide. That's this thing. They gave us 100 moles of carbon. That's this thing. When they give us a number of each reactant, number for reactant, number for reactant, they have given us 2 things, 2 givens, both of them reactants. That means this is a limiting problem. We have to follow the steps. So we are going to have to do 2 fractions and another 2 fractions. That was step 1 and 2. 2 fractions with the first reactant, 2 fractions with the second reactant. So if I'm reading the problem, I know I'm going to do 50 moles of silicon dioxide and 100 moles of carbon. That's my 2 givens. What's a little more complicated on this problem, there are 2 things more complicated. First, there's 2 products to choose from. And number 1 and 2, there was only 1 product. We had to go to this one. And number 2, you have to draw your bridge to this one because that's the only product there is. Here, they are not telling us which product, so you get to just pick. You can just pick whatever looks easier to you, or whatever you want. To me, I'm like, oh, whatever. Let's just do the first one. That's fine. But if you want to draw your bridges over to CO, that's fine too. All that matters is your 2 bridges are pointing at the same product. You can pick whichever product you want, but your bridges are going to point at the same product as each other. That's the important part. You'll also notice that this is not balanced. I'll put my little chart up here. 1 silicon on each side at the beginning, 2 oxygens on one side, 1 oxygen on the other, 1 carbon on each side. So this side with only 1 oxygen, I need there to be 2. When I put this 2 here, that also distributes to the carbon. Now there's not 1 carbon, now there's 2. So on the other side where there's only 1, I need there to be 2. And then it's all equal. So this is 1, 2, 1, 2. Okay. I know that was kind of a lot to throw at you, but either way, balancing is a separate issue. The important thing here is when there are multiple products to pick from, you can pick whichever one you want. I picked SiC. If you want to pick CO, that's fine too, because you're going to find the same answer for limiting an excess. You'll get the same answer for what's limiting and what's excess either way. Regardless, when we go back to our fractions, I know what goes up must come down for both of them. I also know that when I get moles on the bottom, that's when I use my bridge. So moles of SiO2 is 1. My bridge is pointing at 1 SiC, or 1 mole of SiC, because that bridge is a mole bridge. Mole bridge, toll bridge. For my bottom set, 2 moles of carbon are in my bridge. And this bridge is also pointing at 1 mole of SiC. So I end up with 50 moles of SiC here, or 50 moles of SiC here. Interesting. It says look at your 2 answers of moles of product, find which one is larger and cross it out. These are equal. When these are equal, then neither is limiting and neither is excess when these come out to be equal. You could still find how many grams of product, because either way you get 50 moles. But how do you know which one's limiting? Neither will run out first. Because they both make the same maximum amount. I'll leave the bonus to you. I want to point out something on number 4 before I let you work on 2 and 4 yourself. Number 4, you do have to balance. You're going to have to balance this. Number 4 also is giving you grams of one thing, moles of the other thing, but for both of them, it wants the number of grams of product. So you are going to be able to pick whichever product you want. That part doesn't matter. Wherever you want to draw your bridge to is fine. But notice one of them is moles and grams. So that's going to be 3 fractions. And the other one is grams and grams. That one is going to be 4 fractions. So just keep an eye on that when you get to number 4.